Hello everyone, welcome back to my channel Learn SQL with Shahid. In last video we are discussing about MDF architecture where data can be stored. Okay, if we create any database, inside database we have primary file group. Okay, inside primary file group we have MDF and NDF. Primary file group is logical. MDF NDF is it is physical. Okay, so inside that we have extents. Okay, collection of 8 pages is known as extent. Okay, for example, we have one page capacity is 8 KB, so 8 into 8, okay, 64 KB for one extent. So we have here data page right here. So this data page capacity is 8 KB, and one extent means it has 8 pages in it. So whenever we create a table, right, table as SQL Server for extent, not pages one by one, like give me this one page, second page, third page, fourth page, like that it won't ask. It will ask SQL Server to give extent. Okay, whatever, whichever the users who create the data table, okay, on the database. So for the database it allocates the extent. Okay, so table has every time extent. And also I discussed like 1 MB is equal to 128 page, means 1 MB storage capacity if we have, then we'll be having 128 pages. If I go to calculator here, means 1 MB means how many KB? It is 1024 KB, right? So if I divide it by 8, okay, 1024 KB divided by 8 KB means one page capacity is 8 KB. Okay, so how many pages we can create? 128 pages we can create. This also I discussed. And minimum unit of storage is called as page, and minimum unit of allocation is known as extent. Okay, unit of allocation means collection of 8 contiguous pages. Okay, and like pages is stored in the form of unit. Okay, unit of storage. So the page size will be 8 KB here, and also we discussed like this in that 8192 KB, 96 byte is the page header. Okay, 36 byte is the row offset, and we have total if we had 96 plus 36, we have 132 bytes of metadata. In that pager has the information, page header has the information about the rows. Okay, row 1, row 2, row 3, and also if it is free, this page is not allocated. Okay, so it has the free space information as well, and also this 36 byte row offset, whatever the pointers is there, no, like this row offset has the address of the row where it is located, this row where it is located, and its location and all it knows. Okay, so that is the main thing for row offset. And if we add 96 plus 36, we will get 132 bytes of metadata. This one is there, no, it is metadata. And whatever the other remaining 8060, if we minus this 8192 KB minus 132 KB, then we will be having 60 bytes. This is bytes. 8192 means 8 KB means 8192 bytes minus 132. So we will be having 8060 bytes. Same thing here I have explained. And page header has the information about the rows and how much free space is available. Row sets has address of the row. So it might have cleared. Okay, now we'll be continuing next. In last class we discussed these things and all. So to understand better, I am explaining once again. And also I have explained it like whenever we select data, insert, update, or else delete, it has to whenever user query here, right, like update, for example, it will bring the data from data file, that is MDF file, to buffer full, and then 8 KB, it will bring 8 KB pages to buffer full, and then it will modify. Okay, And also I discussed this big int, what is int, small int, tiny int and all. And we have char 200, it is fixed length. If I give some letter SHID, it will consume overall 200 bytes, and varchar of 200 means variable length. Okay, if I give Shahid, it will consume only 6 bytes. If I give some other name, okay, for example Muhammad also, it consume 8 bytes. Okay, Muhammad Shahid means it will consume 8 plus 6, 14 bytes. So if I give here Muhammad Shahid also, then also it will consume the 200. That is the difference between char and varchar. So I have whatever the row is fitted inside that page, right, 8060, that is known as in row data. Also this stopped in last class. Have this values here. Have s name, S number, S name, marks, remarks, everything here. In the student table, if I calculate this 4 bytes int, 4 plus 50 plus again 4 plus 200, 256 bytes in one row. And if I divide that by 8060, which is actual data, we will be having 31 rows inside the page. Okay. So for 5 MB data, like 19,840 rows will fit in inside that. Okay, in 5 MB row data. So like I have already said, like 1 MB 1 MB capacity is 128 pages. So so this I said yesterday. If I go to calculator again, 5 into 128 I can calculate. 1 MB means 128, right? Like 5 into 128 is equal to 640 into 31 rows. Okay, like this much row can be fit into that 5 MB capacity. Okay, whatever the size. Also I have explained this maximum length of char, this much, it is the maximum size. Char we can give like char of 8000 here, char of 8000 here, like this we can give. And maximum length of varchar is varchar max. Okay, if we give this, it uses for large object data, to store the large object data, like images also, text also, whatever it is. So whatever the data is fitting inside the row is known as in row data. So I will be proceeding with row overflow data. Row overflow means row overflow means whatever it is exceeding. Like for example, same example I will take for this. I have I will consider this 4 plus 8000. Here I will give values, some values here. 4 plus something like 8000. Okay, char of varchar I will give. Okay, varchar, consider this as varchar of 8000 plus 4. Again some varchar of 8000 or varchar of max you can consider. Varchar of max. If I give this varchar of max, if there is some huge amount of text in the column, I will give this yes, for 4 I will consider as s number. Okay, plus s name plus marks I have given, right? So again remarks. So for s number, this int, right, this one int, I will write it down below this. S number means 4 byte, S name means 8000, marks again 4 bytes, remarks I will give varchar of max. It can go whatever, like if I give here remarks, I am good at studies, for example. Okay, whatever here it is. Okay, some around 20 letters, for example. So a space also it will consider. Okay, here if I give space also it will consider. That has bytes only. So like this, if it considers 20 byte also, 20 also, it is variable, no? 20 only it will consider. Okay, if there is something like a huge data, like writing 500 MB to 1 GB or 2 GB only, then what happens means, in this case row will not fit inside. Okay, it is exceeding. Okay, for example, it is exceeding varchar of max, like 8000 only you can consider. Okay, 8000 plus 8000 means 16,000, 16,000, 16,008. Okay, something like this, for example. Okay, 16,000 character. Okay, in one row. If it is not fitting inside, okay, this varchar, if it is not fitting inside the row, then it will, there is a 24 byte pointer maintained. Okay, in that actual what it does means, it will move that column, okay, whatever the large object data is there, to this large object data in the from the database to here. Okay, so then what it does means, whenever it modifies right here, whenever someone will again update here, it will come back to its original position, or somebody if they want to modify, then it will remain same here. Okay, so what this means, like it is overflowing, and a 24 byte pointer is maintained. Okay, that is known as row overflow data. So this is in special scenario. If we give varchar of max, at that time we will find this. Okay, if a row is fitting inside okay, 1608 for example, this is not fitting, then it goes out of the scope. Then if it has everything well maintained, like for example, it is exceeding, this is for one row I am giving. If it exceeding like if it exceeding 8060 is there, no, 8060, if it exceeding, okay, whatever the varchar of max is there, if it is exceeding, if it goes 8 2060 something, then large update data, it will data page will point towards the large update data by 24 byte pointer. So that is known as row overflow data. So I have explained in row data. Row, if it is fitting inside the page 8060, then it is in row data. If it is exceeding 8060 byte, then we have a 26 byte pointer pointing towards large update data, which is in var binary max or varchar of max in special scenario. Okay, in such cases we have LOB, that is known as LOB data. Large object data is stored in special LOB data object that is live in separate LOB data allocations. Okay, so hope you might have understood this. Let us proceed with the data types. Okay, we have 8 types of data pages. Okay, like not data page, we have 8 types of pages. 8 types of pages means we have a data page, index page, and also have LOB data. As I discussed now, that is LOB data, and this page free space data we have, and we have gamma SGAM. Okay, SGAM. The GAM means global allocation map. SGAM means shared global allocation map. And we have IAM page. Okay, index allocation map page. I will be showing with demo. Okay, these things and all. Just I am going through now theory. After when times comes, I will be explaining in depth about this. What is IAM page? What is data? Everything I will be opening that page and I will be showing you guys. Okay, And also we have BCM page and DCM page, means whenever we take the backup, right, at that time this changes occurs, okay. And DCM also same thing, like full at the time of backup, what is backups, what is restore and all I will be discussing in future. So I will be discussing now about this data page. Okay, data page contains data stored in the tables. As I show, like a S number, S name, and also marks, remarks. That is the student table. Table. Okay. As I showed, 96 bytes plus 36 bytes, that is metadata inside the database, okay, whatever the user database. What in the data page means 8060 data is showed, no, contains data, that is actual data that is storing inside the data page, everything it is it has that data, okay, actual data. And index page, it contains data related to indexes. I will be discussing this in indexes topics, like we have clustered index, non-clustered index. So what is that, and also that it contains data related to indexes. I will be discussing that in future. And text images, okay, contains large object data, as I shown, like in above example. We have LOB data, like nchar of max. Nchar of max means nothing but if we have varchar of max, no, like as I said, SHA is 6 bytes, it will consume, okay. In case of character, char of 200, it consumes overall 200 bytes. In varchar of max, it will consume 6 bytes. In this case, if I type letter A, okay, it will consume 1 byte, okay. In this case, what it happens means, if I type A, okay, only one letter, then it will consume 2 byte, that is NVARCHAR, okay. So that is the difference between varchar, char, and NVARCHAR of max. Now, not no need to scratch your head on this, because the developer will handle these stuffs and all. So one more main important things, whatever the three pages there, no, this is actual data, it consists, okay. So all the both three types of pages stores user data. And this rest all below, again I have this page free space is there, no, page free space, and gam, sgam, iam page, and BCM and DCM pages are there, no, that 5, okay. You have to keep in on your fingertips, like this 3 stores actual data, data page, index page, and text image, large update data, okay. That is actually storing the user data. And this below are the metadata means I will be explaining this. You have to keep in mind that we have actual means whatever the user data we have, this data page, index page, and text image, this whatever the metadata is there, PFS, okay, PFS, gam, sgam, IAM page, BCM, and DCM, that are the metadata, okay. I will be explaining this page free space. What is page free space means, it contains information about the each page in the database, okay, like whether it is allocated or not, okay, and how much free space is available in it. Each page free space page supports information about 8088 pages, okay, and that is nearly equal to 64 KB, as I say, 64 MB, 64 MB, okay. Like page free space, it has information how much uh, page is allocated, and how much free space is available on pages, okay. Like it has information, it tells the information about 8088 pages, okay. And why it is nearly equal to 64 MB means 8088 pages is there, no, as I said, 1 MB, how much is it? I am having here math also. Already have calculated this. Consider I am creating one DB1 database, okay. It has one page PFS page, okay, page free space. Page can provide, and also this whatever this is there, no, this page free space is there, no. It tells the story about the pages. Okay, that you keep in mind. Whatever the SGAM, GAM, IAM page, BCM, DCM, it tells the story about the extent. You can note it down. This also is the important point. So this page free space tells about the story of 8088 pages. Okay, one interval is 8088, and second interval again it starts with 8088. Okay, first interval is 8088, second interval is 8088, like this. Third interval is 80, like this goes on. Okay, 8088, like this it goes on. First interval, second interval, like that. Second interval. Once it completes this 80 page, it allocates another 808 pages. That is the meaning of that 808 pages information it provides. Okay. Just in simple, one page page free space provides information about 8088 pages. Means here, if I have 8088 pages, if I divide it by 128 pages, means as I said, 1 MB equal to 128 pages, right? In my previous examples and all. That if you divide it by 8088 divided by 128 means it is nearly equal to 64 MB. That is only I was supposed to explain. So it is 64 MB nearly equal to. And page free space, whatever the metadata is there, no, like see here, it will be in the form of this, but not accurate. Okay, no one, Microsoft has also not revealed about how they are storing PFS. Like it is in the form of this only, 0 into 0. Like if in the case in between here, if it is here, if in the case if it is 0, here somewhere it is 0. If I see either 0 into 0, then the page is free. Okay, it tells the story about the how much space is free inside the page. Okay, 0 into 0 means you consider this one page. Okay, this is second, this is third page. Means one page has 8 KB capacity. What I am trying to explain here means they are storing the data in the form of, means a page free space has this format. Okay, they're storing like this. How much page is free inside the data page, that is 8 KB capacity. So it is telling the story how much it is allocated, how much it is free. About that it is telling. Okay, in simple words. So it has till 8088, like this uh, it will limit. Okay, it's till 8088. Okay, so 8088 pages means 64 MB, that is nearly equal to 70. Or I have also this example is there, no, like if you divide, okay, means if you multiply by 8 KB, 8088 pages, one page has 8 KB capacity. So if you multiply 8088 into 8 KB, then you will find here uh, this much value. Same thing, like I will calculate and show you. Here 8088, okay, one page PFS page into 8 one page has 8 KB capacity is equal to 80 divided by this is in MB right now. This is in KB, sorry, this is in KB. If I divide 1024 KB means 64 MB, it has 64 MB. Okay, you can say like 8088 pages are 64 MB interval. So again after it completes this, right, after filling again it has a second time also, a second interval, it will continue the same thing like this. Okay, till 8088, till 8088, same thing like this it will continue. Okay, this is what I wanted to explain you guys. Now hope you might have understood what I was trying to explain. So in simple word, no need to worry. Just these things and all why I am saying means for your better understanding. So everything is theory only. What I am explaining with example. So this is the data, and this tells the story about the pages. Okay. So I will go with other topic like I have said another page type, right? GAM and SGAM, global map allocation. Okay. This one global allocation map and our shared global allocation map. So before going to this topic, what is GAM, SGAM, you need to know about the extent, because this GAM, SGAM and this IAM, BCM, DCM pages and all tells the story about the extent. Okay, so that is the important thing to know, you guys. So what is extent? Okay, extent are the basic unit which space is managed. Okay, an extent is 8 physical contiguous pages. As I explained, 8 pages that has 8 KB capacity, and 8 continuous pages are consecutive or contiguous, whatever you can say, or continuous pages as well. Extent is an collection of 8 contiguous pages, and it holds 64 KB capacity, because one page has 8 KB capacity. 8 contiguous pages means into 8, so 64 KB. This means SQL Server database has 16 extents per MB. Why? Because we have 16 extent per KB means, in previous example, I have said a lot of time that we have 1 MB equal to 128 pages, right? So maths will become very easy. Map for 128 pages we have, no, divided by like 8 continuous pages, right? Extent means so divided by 8 equal to, it becomes for 1 MB we have 16 extents per MB. Okay, 128 pages means. So maths will become easy. 128 pages divided by 8. Okay, 8 pages means 16 extents per MB. So again for 2 MB, how much it will become? 2 MB means 16 into 2, that is 32 MB for 2 extents. So the math will become easy. SQL Server has two types of extents. We have uniform extent and mixed extent. Okay.